Hi, my name is Christian Madali, and this week we are going to tell you about useful science experiments which you can do at your home. This week I'm going to tell you about biodegradable plastic. Biodegradable products. Biodegradable products are those that can be decomposed by microbes and other natural biological processes. Exposure to moisture, air, and the elements enhance that breakdown. Biodegradable products include those that consist of food waste, paper, wood, and fabric. In the absence of moisture and air, decomposition slows and methane, a greenhouse gas, is released. Landfills. Although much of what ends up in landfills is biodegradable, it won't break down if it is not exposed to air and moisture. This prevents the microorganisms from decomposing the garbage quickly, unlike what happens when biodegradable materials are composted. Composting is a process which consists of chopping up waste, stirring it, and keeping it moist. It provides microbes with correct conditions they require to break down organic matter. Bio-based plastics. Bio-based plastics such as starch blends, PLA, Bio-PET, and Bio-PE are mostly used in packaging applications. They are also used in fibers and textile sector. Bio-based succinate acid is suitable for several applications in sports and footwear, automotive, packaging, agriculture, non-moving, and fibers applications. History. When biodegradable plastics were first appeared on the market in the 1980s, manufacturers made claims about them that they could not be verified. This resulted in misinformation and skepticism in the marketplace. While some of these materials were actually biodegradable, many were not. Consumers had no way of distinguishing that what was what, until the Biodegradable Products Institute certification program was created in 1999. And now I'm going to show you how to make your own biodegradable plastic. So first you need some flour, and you need water, and you need oil. First, put in your flour. And then keep pouring in water and keep mixing it. You keep adding more water as you're making. You need to keep mixing it until it becomes in a mixy, until you can mix it and it feels like milk. And then you add oil. Then you mix it. And then finally, you need to put it in a microwave for 30 seconds. And then you take it out. And you have your plastic inside there. And then you take a spoon and then you carve it out. And here is the plastic. Before you use it for anything, you might want to let it cool down and harden up. Because if it goes into water, it'll get soggy and it'll start to rip. So that's the biodegradable plastic.
Hi everyone, my experiment is about running a clock using potatoes. In general, we are using this battery to run a clock. It's just a metal tube filled with powerful acid. Instead of using this, I have created my own battery using potatoes. We can also use tomatoes, oranges, or apples. The potatoes cannot conduct electricity on its own. So I have a zinc plate and a copper plate and connect them with a wire and insert them both into the potatoes. Then I got the negative terminal of the clock and connected to the zinc plate and the positive terminal of the clock and connected to the copper plate. And then I insert them both into the potatoes. And now my clock works. The potatoes in combination with zinc and copper act as a battery. The potatoes contain phosphoric acid, so the zinc reacts with the acid inside the potatoes. Also, the zinc and copper react with each other and produce chemical energy, and electrons flow through the potatoes. Here, the chemical energy is converted into electrical energy, and that is used to power the clock. The main purpose of this experiment is we can use vegetables and recycle them to generate power to help solve energy problem.
Hi, my name is Salawat. Today my experiment is about anemometers. I will tell you how to build your own anemometer with the items available at home. What is an anemometer? An anemometer is a tool that helps measure the wind speed. Anemometers are used in weather stations across the globe. An anemometer was invented by John Thomas Rodney Robinson, a scientist in the United Kingdom in 1846. How anemometers work. The constructed anemometer will rotate at the same speed as the wind. You have to count the number of times the anemometer spins, and that will equal the revolutions per minute. Then you have to measure in feet the circumference of the anemometer. After you do that, you have to multiply the revolutions per minute with the circumference, and the answer to that will be the velocity of the wind in feet. The materials required for this experiment are a water bottle, 3 wooden doubles, 5 medicine cups, a paper puncher, and glue. Procedure. Make holes on the medicine cups roughly a ½ inch below each rim, as you could see on these 4 cups. Push and glue the wooden dowels through the holes of one of the cups as shown. So you push and push it through the hole in this cup. Now repeat the step 2 with 2 more cups and a double. So you have to do that like twice. Now glue the above 2 assemblies, these 2, in the middle of another cup by punching the holes as shown. So you have to make holes in here and push these 2 structures in. Now punch a hole through the bottom of the middle cup and glue another double. So you have to make a hole in the bottom and push a double through. And now if you have a bottle cap, you have to make a hole in that and then put this whole structure through. Okay, now I'm going to show you how it works. So as you could see, it's spinning, and you have to count how many times it spins, and that will be the revolutions per minute. And this is the circumference. You have to multiply that, and you'll get the velocity of the wind speed. The purpose of my experiment is, the purpose of an anemometer is to predict the weather. For example, if meteorologists predict with an anemometer that there is going to be a hurricane tomorrow, we could get ready for the hurricane and we could be more cautious and be safe. Thank you. Bye.
Hi, so what I'm going to talk to you about is process of instant ice. What you need: keep 2 purified water bottles 2 hours in their freezer, ice cubes and a bowl. Take a bowl and put ice cubes in it. Take 1 cold water bottle. Slowly pour it inside the bowl of ice cubes. Now you made a type of slushy instant ice. Here's the experiment right here. And now you can see you made this type of slushy ice. You can actually eat this. It's purified water, so it's fine. Here's it again. How the instant ice is forming. Pouring the water into a bowl of ice cubes forms a slushy ice. As the super cold water hits the ice cube nucleus in the bowl, the crystallization spreads up in the stream of the water as it gets poured on the pile. The latent heat that is released during the freezing process stops it from freezing solid. Here's a picture of it right here. Experiment number 2. Take a water bottle from the freezer, then strongly hit the water bottle on the table. Now we can see the ice in the water bottle. There's ice that formed in the water here. How the instant ice is forming. Water normally turns to ice at 0 degrees Celsius, but the bottles were exposed to -8 degrees Fahrenheit, -22 degrees Celsius. A liquid can remain fluid below its freezing point if it is pure and cooled slowly. This is called supercooling and can be undone by firmly hitting the water or putting an ice cube, and the other term for this process is called a snap freeze. Here it is. Here's a picture of the experiment. Here's the starting, and this is how it ends up. Why impurified water cannot make the instant ice on both experiments. When water freezes, it needs a nucleus in order for the solid crystals to form and start to become ice. However, purified water by definition doesn't have those impurities. With nothing for the water molecules to latch onto, purified water can be super cold as far as -40 degrees Fahrenheit. I'm done.
Hi, my name is Rudvika, and today I'll show you 2 experiments. The first one is gonna be changing the direction of this arrow. For this, you'll need an arrow, of course, a cup or a glass, and a glass full of water. So first, you'll take the cup and keep it a few distance away from the arrow. Can you see the arrow through the glass?
Yes.
So, now, which side is it pointing to?
Right.
Right, this side. So, we're gonna take our water and pour it through this glass. Now, which side is it pointing to?
Left.
Yes, this side. Why is this? Because light traveled from the air through the glass, through the water, and back through the glass before hitting the arrow. This is called refraction, and this is why this happens. My second experiment is water fountain. For this you'll need a water bottle with a straw, and we made a hole in right here and we kept the straw in. So you'll need this that we made, and water fill up, a bowl, and a balloon. So first we'll blow up your balloon. And you may want someone you to help with. And you'll just keep the balloon's top on top of the thing. And now the water is coming into the bowl. Why is this? The air inside the balloon is under pressure, so the air pushes the water and it comes out through the straw. And here's an example of this. In India, there's a pump, and you use your hands to pump it. And this is the same exact reason. That you're pushing the pump, and it acts like the balloon, and then it pushes the water, and it comes through the spout. I hope you like it. Bye.
Hi guys, my name is Varshit, and today I'm going to talk about egg in a bottle. What do you think is inside of this bottle? There's actually air inside of this bottle. Air is made out of atoms. My science experiment is about air pressure. What you need to do this experiment is a bottle and hard-boiled egg, a piece of paper, and an igniter. This egg doesn't fit in this bottle. So what you need to do is light this piece of paper and put it inside of this. Then I'm going to seal it with the egg, and let's see what happens. For this, I'm going to need my dad's help for the fire part. As you see, the egg went inside. Why didn't it go the first time? Was because of air pressure. Air pressure is something that pushes from all sides. So the inside pressure and the outside pressure were the same, so the egg didn't move. When we put the fire, some air molecules got heated and tried to escape from the bottle. Then the inside pressure was greater than the outside pressure, and the egg slightly shaked. Then the inside pressure cooled down, and then the outside pressure was greater than the inside pressure. So then the outside pressure pushed the egg in the bottle. These are some advantages for using air pressure: a vacuum cleaner, a tire, and a pressure cooker. Thank you.
Hi, my name is Darvik, and I'm going to tell you how to do the homemade fire extinguisher experiment. So what you'll need for this is a lit up candle, vinegar, baking soda, a matchbox, and a glass. So the baking soda is already poured in. So now if I take the vinegar and pour a little bit in, a chemical reaction will happen. Carbon dioxide forms in this chemical reaction. So right before it's done, I need to put my hand over it so the carbon dioxide doesn't flow out, because we need it for the experiment. Now that the chemical reaction is almost done, carbon dioxide is in it. So this fire needs oxygen to use. So carbon dioxide will take away all the oxygen, and the fire will go out. This will like this. That happens because the fire needs oxygen to live, and carbon dioxide will take away the oxygen. This can be, in the real world, this can be used as a homemade fire extinguisher. This is my experiment. Bye.
Hey guys, I'm the robber here. I'm gonna get into that house and steal all the money. So, let's get in. And hopefully, we don't get caught. Whoa, what was that sound? Oh no, what was that alarm? Is there a crime scene here? There we go. Oh no. There we go. I'm the spy here. I'm the one who set up this trap. Every house. Because there's been a robber. So we decided to do something to stop it. So I made this alarm. So what it technically does. So I'm going to explain how it works. So there's 2 wires here. And so they're like this much space between. So when it connects, it'll make a sound. But how the sound comes, you see these like stiff things? They act like wires also. So first it goes into this alarm thing, then it goes to the speaker, and then the sound will come out of it. And that's it. Thank you. Bye. And if you see any more crimes, please contact me. Bye.
My name is Harshit. For this week, my topic is solar cooker. The solar cooker was first invented by Ernest Sherman. He invented a solar cooker by help natural resources. So, how does solar cooker work? A solar cooker works with the sun's UV rays, and the sun's UV rays convert into energy, and that energy cooks food. So this is our solar cooker. I made it with homemade supplies, like cardboard, foil, and stuff. Those are the main supplies for the solar cooker. So inside the solar cooker retains heat up to 150 degrees Fahrenheit to 4 degrees Fahrenheit. So this is a reflector. So the sun's UV rays, it falls on this and this reflects it onto the glass. That's what's called a reflector. So the purpose for this solar cooker is instead of wasting electricity, gas, and fuel, why don't we use natural resources? So solar cookers can be used to help global warming. So it's been 4 hours since they put some dal and rice. Let's see what happens. This is the rice. So this is cooked, and it cooked, and also there's something it cooked. Yep, it cooked. Everything has been cooked. So I hope you like my topic about solar cookers. Thank you, and see you later.
Hi, my name is Adamshi, and today I'm going to tell you about my magnet experiment. Here are the things I used for my spinning pencil experiment. I used styrofoam, skewers, cardboard, and magnets, and a pencil. This pencil is standing because all the magnets are repelling each other. Now I'm going to spin it. It's going to spin for a few seconds. Do you know that magnets are used a lot in the modern world? Here, I'll tell you. This is an MRI scanner. MRI scanners use a strong magnetic field and radio waves to generate images of parts of the body that can't be seen using an X-ray, CT scans, or an ultrasound. This is a roller coaster. Roller coasters use magnets by starting, which is called propulsion, and by stopping using magnetic brakes. Also, it's used in a microwave. Microwave ovens use magnetrons consisting of magnets to generate electromagnetic waves that heat the food. They are also used in speakers. This is the core. This is the electromagnet, also known as the coil, and this is the permanent magnet. If you put two speakers of the headphones together, you can feel the magnetic force. But don't do this too much. Bye!
Hi, my name is Sung, and for my experiment, I will show you how to clean old and rusted coins with ingredients that you have at home. First, you will need vinegar or any liquid which is high in citric acid. My vinegar only has 5% acidity, so I will also add some lemon juice. You will also need an old rusted coin which is even turning green, a string, and some tape. First, attach the string to the coin with some tape. Then, take some vinegar and put some in the glass. I will also be adding a spoonful of lemon juice. Now, take the string and lower it into the glass until half of the coin is in the liquid. It will take about 30 minutes for the coin to be clean. By then, I will tell you the reaction that is happening. The copper coin turns green or rust because it is exposed to the oxygen in the atmosphere. But when it is exposed to the citric acid in vinegar or fruit juice, the citric acid dissolves the copper oxide. So you get a shiny and clean coin. Okay, so now 30 minutes have passed. Let's see the coin. Wow! Half of the coin is clean. Let's take it out for a closer view. As you can see, the part of the coin that was in the liquid is now clean. Remember that after you take the coin out, you have to wash it thoroughly and also dispense the liquid. Now, do try this experiment at home. Bye!